can see videos in this video. Wonderful. Okay, so thank you very much for this opportunity. My name is Sudipta Ghosh. I'm a partner in PwC India as I lead the data analytics practice and also I'm a partner and actually worker. I wanted to take the next 20-25 minutes on the subject of AI-driven next gen supply chain. I will try to share my thoughts in the next 20 minutes or so, 20-25 minutes. And then if there are questions, we will take that up. What I wanted to cover was here 5 things. Setting the context in terms of what are the creation of organizations, in terms of their decision-making process as far as supply chain is concerned. I talked a little bit about building a resilient supply chain using digital tools. Then I will also try and cover the concept of demand sensing in addition to demand forecasting for anticipating changes. Beyond the challenges around unknown unknowns, I'll cover a little bit about anomaly detection. And last but not least, I will briefly touch upon the understanding of behavioral patterns from transactional data using process mining. If you're unable to hear me or you cannot see me, just let me know because I will not be able to see all of you. So you will have to tell me if you are not able to hear me or not able to see my screen. So in terms of setting up the context, what we do is that we conduct a lot of surveys with our clients. Typically, these are supply chain leaders, CEOs, and there's one a lot of things which have come out in a very consistent manner. And this slide shows some of those. And what we have seen is that most of the organizations are talking about resilience, flexibility, and efficiency of the supply chain. Efficiency was always very important, anyways, but what has changed the narrative a little bit is a lot of focus on when you introduce more resilience in your supply chain, and that might mean that you have to possibly trade off, have some trade-offs, and that might be some costs, but still more further. The other consistent theme which has come across is that this function, the supply chain function, has become very critical, and many organizations are actually talking about digitizing the end-to-end process, looking at the visibility of the entire chain from end to end, and also looking at improving the entire integrated plan. So those are some of the key things which we are hearing from our clients and from the industry leaders. Now, in that backdrop, because the subject is AI and supply chain, I thought I will share with you some of the cutting-edge experiences which we are hearing and we are doing for our clients. So the first one I wanted to talk about was understanding the external disruptions. So when we are looking at the supply chain can get disrupted in any of these 4 categories. There could be a disruption because of an unexpected change in the demand. That unexpected change in the demand could be because of geopolitical reasons, could be because of an external environment, could be because of competitor action, and many other things. And hence, that introduces a good amount of disruption or changing patterns in behaviors of customers. In addition to a demand disruption, we can have logistics disruptions. Now, that is something which can happen, and we have seen that happen, where the supply chains are not as reliable, or they take time, or if your supply chain is very complex and cuts across multiple territories or countries, and it's very vulnerable to those disruptions. We also see supplier disruptions. So, for example, particularly if you are importing raw material from a different country, then the vulnerability is even more. Even if you are not, there is a possibility that suppliers may just go out of business or may not be able to serve you and all that. So supply disruption is a real challenge. And then last but not least, disruption around the production processes where there could be unexpected breakdowns or there could be challenges around people and cause challenges. So there are four different categories of disruptions. Now, when we are talking about the digital twin, the starting point of the digital twin, and I take an example here, which is a very simplified example of the slide that you can really more complex and easy. But if you see from the left side, you have suppliers, and then suppliers are supplying, and there is a stocking point up, and we have I have just made the supply chain a little more representative, like you are importing from two different countries. And then, of course, you have a stocking point, which is there in India, for the raw material. The production and the finished goods is happening in India, and then it is being shipped to other countries who are your customers, and the finished warehouse and products are over there. Now, in each of these points, that either the production or there is stocking, there are different parameters which you can capture as way of by way of digital twin. So you can really have information about the reorder point, about the initial inventories, about the time it takes to move from point A to B, and also you will have a demand pattern which you can simulate. And then in these initial conditions, you can create a model which would effectively simulate the entire function of the supply chain. Now, an additional interesting thing you can do is that you can introduce elasticity in the entire supply chain. So, for example, if you have a lead time of 5 days, say from supplying from a raw material store to a production factory, it is not always possible or always likely that every shipment will exactly happen in 5 days. Some shipments can happen on 6 days, and some can happen on 4 days. So there is always going to be a elasticity or a variability, even just for the lead times. And if you look at the frequency distribution of that, you will be able to see whether it is common distribution or any other distribution. And for any kind of such distribution, we will know what is the mean and what is the median of that distribution. So, in a simulation, what is we get based on your understanding, and that makes the digital twin a little more realistic. So when you overlay the stochasticity with the norms of the supply chain along with the demand pattern, then you are able to look at some of the key matrices or outputs from this. So what you can do is that you can look at the service levels as one output, and you can look at the inventories at different stocking points and other order. And you can pretty much measure that for every simulation run, what has been the service level and what are the inventories, right? And you will be surprised to see that because of the stochasticity itself, even if there are no external disruptions, your service levels are not going to be very consistent because you would find the variability. And what you can see there is that you will have a possibility that in this example, you can see that we are looking at a service level where we are achieving a figure of 97% in 60% of the cases. Right? And then you also have the raw material inventory levels. And what you can also do is that you can kind of a realistic scenario, an optimistic and pessimistic scenario, and then you can see that whether you are going to fill or stop out at any point in time. Now, there are two things you can do here. One is that even before you have introduced disruption, you can see that if I am able to reduce the variability or reduce the sigma lead time, then how does that impact in terms of the service levels? And the other option you can do is that you can reduce the mean time. So, for example, if it takes 5 days for you to ship, can I reduce the mean time to 4 days or 3 days, and that will help you. Now, almost mathematically, you can use these multiple options and see the impact of that in terms of your services and your implementations. Once you have done all of that, what you can then do is that you will introduce discussions. So I talked about the four discussions, four categories of discussions in the previous slide. So what you will do here is that you can say that a discussion means that a certain raw material could not arrive on time, right? And once you simulate that, then you know that if today the raw material is not shipped, then there is a time impact we're talking about in PPI, which could receive the delay for the next maybe 5 days or 6 days for you to do something. But beyond that, you will not be able to fulfill and increase the demand of the customer. Now, when you are introducing particular discussions, you will find that there will be few nodes where you will be very vulnerable in terms of the inventory position. And once you able to find those nodes, then you know that if you have to do for any supply chain, then those are the areas where you need to do. Another important thing, interesting thing which you can do is you can look at the different factors which is influencing about your say customer service or service levels. And in this example, suppose you are looking at two major looking at capacities at 2 points and you're looking at lead times for two suppliers, it will give you which particular input variable has the highest predictive power or correlation with your service level. So that way you can also look at if you have to debottleneck a capacity or you have to increase or reduce the lead time, which areas of the suppliers will be first, right? And then maybe use stability-based model or other models which you can use, which can figure out the value and the correlation between the input and the output variables. Another interesting thing which you can do is that when you are looking at the time to impact across suppliers, and time to impact means the supply stops and what to impact and how severe that impact is. Typically, you would be looking at suppliers and you will be focusing on suppliers which have a very low time to impact, which means that you have to almost immediately use something, and these are the vulnerable uses. However, there are suppliers where the time to impact would be very high, which means that you can possibly relax a little bit there and you can negotiate with them and then look at some of the cost saving opportunities. The slide on the right hand side is an interesting one because when you're looking at the impact, some of the low value items can have a higher impact if it is kind of causing significant losses. So the spend can be low for the supplier, but if the performance impact is high, then these are some of the hidden risks which you need to be looking at. So what I wanted to say is that this is a framework where you are creating a digital replica of the supply chain. You are creating or generating synthetic data by running a simulation. Then you are doing mathematical modeling and AI-based analysis on the synthetic data. You are then trying to find out what are the causal effects, which factors have a maximum impact. You are also trying to find out which points in the supply chain are more vulnerable than the others, and you are also looking at coordinating the capacity and the suppliers based on these analysis. So that is one application of AI in terms of improving the resilience of your supply chain. Talking about demand forecasting, but what essentially happens is that the demand network aspects One is the outside in perspective, which is deeply discount, and that outside in perspective is where there is a lot of unstructured data which is available in the public domain. Sometimes they're available from the databases which organizations subscribe to. Sometimes it's available from analyst reviews and other experts who give their comment. And of course, you also have a lot of structured data which comes from external sources as well. And when you look at all of that, and of course, generative AI as well, which also simplifies some of these abilities because you can streamline the search and the summarization in a very large, unstructured, text-based data set. And then you can use that for generating alerts, which will have, or you know that they will have an impact from a demand perspective. Right? So this is the framework which we use for sensing the demand, and then once you have sensed the demand, that goes as an input into your forecasting model. So in addition to all your data sources and your historical data and your data about events and data about promotions and everything else, we incorporate that, and that helps you have a more balanced demand forecasting when we are looking at both the outside in perspective as well as the inside out perspective, and combining the two makes your forecasting process sentient or more adaptable. And that is something which we have seen many organizations doing. We are also working with organizations in this space. So that is the impact or aspect where AI is used heavily for understanding the demand a lot better. Now, if I move on to the problem, we all know that you always have something which is not going right. So there could be anomalies. There could be anomalies when you are doing a procurement. There could be anomalies when you are doing quality management processes, when you are looking at defects. There could be anomalies when you are looking at the behavior of your customers. So this is one subject or one area which is critical because some of the disruptions or hidden disruptions start featuring by just looking at what is happening differently. So AI and advanced modeling techniques help you to detect some of these anomalies. So typically you face a few challenges. So some of the challenges are that data will be stored only in one place and not in an integrated manner. Control mechanisms could be very manual in nature. Some of the known risks are fine, but people find out a way to figure out and I would not say bypass, but address some of those known risks. You are more interested in something which is unknown for you, because this is where some of your biggest risks will come from, so looking for the unknown unknowns. And also the cost of compliance is something which is increasing and we would like to address it. So what we have done is that we have seen there is a possibility for you to do an AI-driven anomaly detection. And this is almost like a horizontal platform. You can apply this to multiple points in the supply chain. What it effectively does is it looks at unsupervised learning techniques. Because of its supervised, it helps you to detect the unknown unknowns. Now, every unknown unknown cannot be a problem because you still need to overlay that data from the perspective of your domain knowledge. And the beauty is that once you have said that this outlier is not a bad outlier, the machine learning algorithm takes over and then it looks back that in the subsequent analysis. Right? The other aspect of this unknown unknowns is the explainability of the model. So, typically, most of these unsupervised predictions can potentially become very black box. You will not be able to understand why something has been as an anomaly. So, what organizations have been doing, and we have also been helping them, is to use either natural language processing or large language models for them to explain why a particular point or why a particular data set is looking anomalous. So you're using Gen AI for explaining the reason for that anomaly so that it is easily understood by someone who is not very technical or very mathematically oriented. So it's a combination of unsupervised learning with Gen AI coming together to give you an easy to use solution where you can continuously track and see the anomalies coming in across your supply chain and if you are able to address them, then you will be able to run very smooth operations across the entire chain. Right? I mean, you can do invoice monitoring, you can do procurement, you can do predictive maintenance, you can reduce the cost of food quality, you can figure out the golden bag, multiple things can be done. The last one, which I would like to call out, is what we are seeing is from a process mining perspective. So now what happens is that in any transaction system across the whole supply chain, we have multiple transactions which are happening. It is possible now for you to look at that entire transactional data, look at the raw data, the timestamp of every transaction, and reconstruct the process from beginning to end by looking at the timestamps and helping you to find out what is the end-to-end flow transaction by transaction. And that is a great way to transaction to have your entire supply chain. It does is that it helps you do three things. The first thing it does is that it helps you identify whether there are any process weightages. So are you doing everything in the same way or do you have multiple exceptions which you are applying to the system? And if there are no exceptions which are applied, you know that your processes are not standardized, so there is an opportunity for you to standardize the process. The second thing it allows you to look at what is the turnaround time or the end-to-end time it takes to complete a transaction. So, should be supply, you know, possibility is of walking images and sorry, so and all these possibilities so that you have the right pieces when you evaluation. So that's how some of the stuff which I said. So basically, what I wanted to talk about and summarize is that we are seeing a huge amount of application of AI in the entire supply chain, right from the point of view of addressing efficiency, resilience, understanding of behaviors, looking at the anomalies, and trying to improve the entire effectiveness of the implementation. And I thought I would just give you a very quick glimpse of some of the examples or use cases of how AI is now used very effectively for addressing some of the business issues which organizations are facing as far as the supply chain is concerned. So I'll take a pause and if there is any question, I'm more than happy to answer.